Let's look at a couple more examples. This one, we are starting with a log base 1/2 of x, and our transformed function is log base 1/2 of negative 1/2 x. So I see two things going on here. The first is the negative sign. Remember that negative signs that are out in front of x or out in front of the entire function are treated separately from any number that might be right behind them. So this negative sign inside with x means that I am reflecting over the y-axis inside with x. The next thing that I see is a 1/2, again inside with x, so I have to think opposite. Here in the equation I am multiplying x by 1/2, but I need to state this as the reciprocal. So I need to state it as a horizontal stretch by 2. Remember that those are the kind of funny ones. We have to think opposite, and in this case opposite, the opposite of multiplying by 1/2 is multiplying by 2. All right, so we have not moved our function left or right, and so my asymptote is still going to be at x equals 0. However, I have reflected over the y-axis. So think about what that means. That means that anything that was a positive x over on the right-hand side has now flipped over and become a negative x. So my domain is going to be affected here. My domain is going to be x is less than 0, not greater than 0. So again, I would encourage you to highlight that less than and highlight the negative sign inside with x this time in order to remind yourself why that inequality symbol is the reverse of what we typically see. It's because our graph has been reversed. It's been reflected to affect x values. All right, finally, my range, can't do anything to change that. It's going to be all real numbers. I would like for you to try this last one, identify the things that are different, and go ahead and identify an asymptote, domain, and range. Come back here to see how. All right, let's take a look. So the first thing that you should have identified when you're changing from log base 2 of x to 7 log base 2 of x minus 5 is the 7 all the way out in front being multiplied by our function. And so remember that a number greater than 1 out in front is a vertical stretch by that number. So a vertical stretch by 7. A negative tacked onto the tail end of the function, just like it always has been, moves us down by 5. So I have moved in the vertical direction up and down, but I have not moved left to right. And so my asymptote has not been affected because I didn't change anything about my x values. So x is going to be 0 at our asymptote, that vertical asymptote line along the y-axis. Our domain, well, again, since my asymptote is at 0 and I haven't done any reflecting here, my domain is x greater than 0, just the typical domain that I have for my parent function. Finally, range can't be changed. It's going to be all real number. I have one last example for you here, and this is one where we're going to write the rule for g when we're given a description of what's being done to it. So we are going to translate 2 units up. I'll call that transformation 1, and then we have a vertical stretch by a factor of 3. So I'll say that that is the second one, and we're starting with f of x is equal to log base 1/3 of x. So we will start by writing h of x, which is going to be equal to, we're moving 2 units up, so that's a 2 tacked onto the very end of my function. So f of x plus 2. And when I plug in f of x, log base 1/3 of x, and then plus 2. My second thing, and since this is also the last thing, I'll call it g of x. That's going to be a vertical stretch by a factor of 3. So remember that stretches and shrinks vertically happen way out in the very front of our function. So what's going to happen is I'm going to have a 3 multiplied by my entire h of x function. Remember, it's out in front and vertical. It affects the whole function. So this is what it's going to look like. Pay close attention here. We are affecting the entire function with this because it's vertical. So this 3 has to be multiplied by my entire function. Log base 1/3 of x and plus 2. So as a final step, I need to distribute the 3 to each piece. So this is going to give me 3 log base 1/3 of x plus 6. Don't forget that when you're doing something vertically, whether it's a stretch or shrink out here, or if it had been a reflection in the x-axis, either way, if there is something that is happening vertically out in front of the function, it affects the entire function. So in many cases, you will need to distribute like I just